This is my presentation on the AC sine wave. The AC sine wave has 5 characteristics: the amplitude, the RMS, the period, the peak-to-peak, and the frequency. Amplitude is the maximum current or voltage in a sine wave. It can be represented by either two of the peaks of the sine wave. The voltage level can be referred to as the peak voltage and can be either positive or negative. Positive and negative only refer to the direction of the current flow. Negative values do not mean it has a value that's less than 0, rather than just indicating that the current is flowing in the opposite direction. RMS is the root mean squared, and this is the actual useful amount of voltage that is available. This is the standard way of measuring and reporting alternating current and voltage. It is not the peak, but rather the average value. The RMS is obtained by dividing the voltage peak value by the square root of 2. This leaves us with the actual usable voltage. For example, in this waveform, the peak-to-peak expression is 20 sine omega t plus the phase angle. By applying the RMS equation, we can find that the RMS value is 14 volts and rewrite the equation as 14 sine omega t plus the phase angle, which in this case is 0. The peak-to-peak is the value measured between the peaks of the positive side of the wave and the peak of the negative side of the wave. This value is simply just twice the amplitude. This voltage is the maximum voltage available, but not at all usable in practical applications. Frequency is measured in hertz and is defined by the amount of periods completed per second. The frequency has a defining factor in the total impedance of a circuit that has a capacitor or inductor elements in it. With a higher frequency, the impedance of a capacitor decreases, while at the same time increasing the impedance of an inductor. Frequency can be calculated by using the inverse of the period.